What's up, everybody? Getting started. We're doing a test warm-up. We got a test today. We're going over systems. We got a couple different things going on. A little bit of a messy paper here. Very similar to what we did yesterday. Remember, the test is going to be on the computer. Here we go. What is the solution to the system graphed below? Well, I can see that this is going to have a nice one solution because we have two lines that have one solution. Whenever we do have one solution, we're going to want to write down where do these things actually cross. So I'm going to go ahead and go for the -1, +2. This next one I can see has two lines, and these two lines don't cross. I'm going no solutions for this. Solutions, no solutions. And this last one, there it is. Two lines, they cross, they touch. This is another one solution. And where do they actually touch? Yeah, they're going to touch at 1, 5. There it is, 1, 5. Not too bad. There they are. We've got on the bottom here, graph each system and identify the solution. So let's go ahead and graph these two lines. Going to go ahead and graph -1 with a +2. That's up 2 over 1, up 2 over 1. And I do want this to be a nice straight line because I'm looking for intersection. So I do want this to be nice and sharp as long as I can. If I make all these dots, I know we're going to have an intersection at one of these dots. The other one starts at +5, and this is a -1 slope, which is up 1, left 1. I'm going to go ahead. And we can see where these guys are crossing right here at +2, +3. Doing a little bit of graphing. Hopefully graphing feels pretty good these days. Over here, we're working with a system of inequalities. We're going to look for anything that is in this bottom corner here. And so we're going to need to work with these coordinates one at a time. -1 means left 1. That is not a solution because it's not in the right spot. We have 3, 0. That tells me to go right 3. 1, 2, 3. That is a solution. That is valid. Then we've got 0, -1, 0, -1. That's going to put me right here. That's going to put me straight on the dotted line. And I hope that you guys know, dash line bad. Okay, dash line bad. 4, 0 is going to put me to the right 4. So it's going to be 1, 2, 3, 4. And that's going to put me right back on the dash line bad. And finish it up with 2, -1. 1, 2, -1. There it is. Looks like a solution. All right, work to that. That wasn't too bad. On the bottom here, which region is the solution? Okay, so I need to do a little bit of graphing action, and it doesn't tell me which line is which. I'm looking at this 2 and this 5 to help me out. That's going to be this 2 and this 5. So, if I think about this top line as the one that crosses through 2, it would be that line. And since I have a less than or equal to, that is a below, so I should color down here, working with C or D. And then I'm going to work with this line, which is a greater than. So for my other line, I need to color greater than, which would be that space up there. And so if I'm looking for, I guess I don't really have two colors, I only have the orange. If I'm looking for the one corner, it would be this corner here. This is where all my solutions are going to be found, which is in C. And then I got one more question crammed in the corner here. Is 1, 1 a solution, yes or no? 1, 1 is going to be right 1, up 1. That's going to put me right here. This is a very important question. I remember we did one just like this yesterday. I put a box on it. I told you guys this is important. Remember, dash line bad. I see that we're on a solid line, but we are also on a dash line. Dash lines are bad. No. Why not? Dash line bad. Dash line bad. Let's flip it over. We're just powering through this. You know, we've done these questions. We've worked with these questions before. This is looking extremely familiar. Working through these, we've got the m equals negative 1 over 1, b equals 2. Starting here, we're going negative 1 over 1. And this is an inequality, so it doesn't have to be perfect. Right? For these ones, we're not really focusing on a perfect intersection. We're just focusing on the big picture. Dash line, and I need to color below. There you go. This one is going to be m equals positive 3 halves, b equals 2. So I'm going to start here, and I'm going to be going 3, 2, 3, 2. This is going to be a solid line. Has a nice straight line. And I need to be shading below again. So I'm going to be shading down here. And so that is the region that has been shaded twice. Last one, I threw this one on here again today because we really struggle with it. I remember in the video yesterday I said, is this a horizontal line? Is this a vertical line? Or is this a diagonal line? And I heard somebody say vertical, and I heard somebody say horizontal. But the truth is, this is a diagonal line because we have the y and the x. So we still have the m, and we still have the b. This is a dashed line. And this is a less than, so I need to color down here. Then this other one has the y, but it has no x. So this graph is going to be a Hoy graph, which is a little bit of a side-to-side graph. Starting at negative 4 on the y-axis, this is a dashed line. And we need to shade above this one. So we need to shade all of this, which is above, and that's going to leave me with my corner right there. All right, we're almost done here. Gonna power through 3 more questions. I'm noticing that these x's are perfect opposites, and so I'm gonna cross those out. Those are perfect opposites. They're gonna go away. I'm gonna focus on my y's, negative 10 plus 9. If you're ever not sure, just use Desmos, right? Just go to Desmos, negative 10 plus 9. Don't stress about it. Negative 1y is equal to positive 4. Negative 2 plus 6 is positive 4. Divide by a negative 1, which never changes the number and always changes the sign. So we've got y equals negative 4. Now this is only half the answer. It is the second half because it is the y value, and y's always go in the second position. We take the 4, plug it in. I should say negative 4. And we have negative 6x minus 10 times the y number, which is negative 4. equals negative 2. We do all that. We type all that in. Desmos, Desmos, Desmos. Click, click. And we're looking with negative 6x minus 10 parentheses negative 4 equals negative 2. Now, it looks kind of crazy here. Look how far I'm zoomed out. Let me hit the home button. Here we go. Positive 7. Sweet. Just going to jump straight into the next one. Now, when I do this one, negative 1 plus 3 is 2. 3 plus 3 is 6. So this is a question that I need to rewrite. That's going to be negative 1 turning into positive 1x. Positive 3y turning into negative 3y. 0, which is just 0. At this point, those are opposites. We're going to have 4x. That's going to make 0. That's going to make 12. Simple divide. We're going to get x equals 3. And that's only half the answer. We're going to plug this 3 into the x. Probably a good idea, something that I forgot to do really quick, is just to cross off that top one. Right? We don't need that top one anymore. It's just making things more complicated. We plug that 3 back in there. That's going to give us a whole bunch of 3's for this question. Goodness gracious. We're going to have 3 times x, which we know is 3, plus 3y equals 12. Type all that in Desmos. I'll give you guys a second to do that. And we get 1. And this last question, very similar to the last one. I know that we have 1x and 1x, but 1 plus 1 is 2. So you know what? It is time to rewrite. Negative 1x minus 3y equals negative 9. These are opposites. 1 minus 3 is negative 2. 7 minus 9 is negative 2. Y is equal to 1. And so, plug the y in. 1x plus 1 times 1 equals 7. Type all that stuff in. Calculating. Getting 6. And the very last question here says, cross out the variables that will eliminate in the system below. Too easy for me. Too easy for me. All right. I think that this is enough to prepare you for the test today. The test is, working with a lot of these concepts. Make sure you understand a few things. Make sure you understand this question. Solid line, dash line, dash line, bad. Dash line, bad. Okay? Take your time. Make sure with your coordinates you do them carefully. Make sure down here you plug these values in. Put the y into the y position. Don't put the y into the x position and make a mistake. Make sure you do all that, and I think you'll do well. Good luck on the first test of the semester, and way to go. Proud of you.